This particular trialogue, which is Hawaii, what it tells us about evolution, how it relates to island ecosystems and their evolutionary progress generally, falls to me because in the course of my life, as chance would have it, I visited most of the major theaters of evolution that involve island groups that are considered to be exemplars of the various types of island groups on the planet. Hawaii, where we are recording these trialogues, is of course a group of mid-ocean volcanic islands. The only other mid-ocean volcanic island groups in the world are the Azores and the Seychelles. And they offer great contrast to Hawaii, particularly the Seychelles, which as a portion of the Madagascan landmass have been above water some 300 million years, longer than any other place on the planet. And so the evolutionary processes there offer a dramatic contrast to how evolution has proceeded in the Hawaiian Islands. The Hawaiian Islands represent a unique case because of the size of the volcanic calderas and vents beneath the Pacific floor that have created them. In fact, these vents and volcanic system is the largest on the planet. So what we have in Hawaii is a tectonic plate sliding slowly toward southern Russia and Japan that is crossing over a weak place in the Earth's crust, and a place where the core magma of the planet lies a considerable percentage closer to the surface than anywhere on Earth. And the result of this situation is a series of islands formed in the same spot, but each, after its volcanic birth, is rafted on the continental plate off toward the northwest. The life in the Hawaiian Islands shows 30 to 35 years of endemicism by the ordinary rates of gene change that biologists recognize. Nevertheless, geologically speaking, no Hawaiian island is older than 12 million years. The obvious interpretation of these facts is that life arose out here on islands which no longer exist. And as islands rose and fell, the life hopscotched from one island to another, and indeed the dispersal rates of birds, tree snails, and this sort of thing moving eastward from Kauai across Oahu, Molokai, and Maui to the Big Island show that this gradient is still operable. Kauai is the most the forests of Kauai are the most species-rich forests of the major islands. Hawaii's climax forests are the most species-poor because animals are still arriving here from the other islands. Because these volcanoes are so huge, Hawaii has a complete range of ecological systems from sea level to 14,000 feet, which is virtually the entire range on the planet in which life is able to locate itself. The volcano itself is, in fact, by volume, the world's largest mountain, because what it represents is a 14,000-foot mountain before it breaks through to sea level, because it's rising from the Pacific floor, and in this part of the world, the Pacific floor is 13,000 feet deep. So this island this mountain was enormous before it ever broke water. It now rises 13,000 feet above sea level, and its sister mountain, Mauna Kea, is only shorter by 120 feet. So what has been created out here is a very closed ecosystem, far from any continental landmass. The forms of life which arrive here arrive on rafted debris or tucked into the feathers of migratory birds, or in some other highly improbable fashion. What we see here is a winnowing of continental species based on extreme improbability. As an example, a very common Sierra Nevada wildflower of no great distinction. Apparently, some millions of years ago, a single seed arrived on Maui and has created through backcrossing, has created a mutated race of plants that we know as the Hawaiian silver sword, which is one of the most bizarre plants that the islands have produced. In terms of islands within islands, the fractal adumbration of nature, it's very evident here. For example, because the island is created by a series of flows of varying ages, there is a constant process in which ecosystems become islanded by lava flows cutting them off. And so you have a series of micro-islands of species that develop independently of each other, even though they may only be some few miles apart, but separated by a landscape so toxic and desolate that there is very little intermixing of genes. This is why this is thought to have been a formative factor in the evolution of the Hawaiian Drosophila, which of course were very, very useful in early studies of genetics, because the chromosomes of the Hawaiian Drosophila are 10,000 times larger than the ordinary Drosophila chromosomes, and can actually, in the era before electron microscopes, you could actually color band with certain dyes the chromosomes of these Drosophila. An early chromosome unraveling went forward through these studies. So, in terms of extrapolating all of this particular natural history data to some sort of general model, I think what life on islands brings home to us is that the Earth itself is an island. I've been saying for many, many years that one of the most revolutionary, yet totally trivial and predictable revolutions sure to come in biology is the recognition that all these models of island isolation and species dispersion across oceans can easily be expanded to the three-dimensional ocean of outer space. Very, very clearly, viruses, pions, gene fragments, this sort of thing percolates between the stars as simply statistically a very low component is the percolation of inorganic matter between the stars. Indeed, there have been many attempts to establish this idea of Fred Hoyle and the theory of the cometary origin of life. Some of these ideas have gone forward. It seems to me perfectly obvious that in time this will be embraced. After all, viruses can freeze down to crystalline states that are almost minerals. And as for dispersion between celestial bodies, it's now generally agreed that a number of Antarctic meteorites that have been recovered are in fact fragments of Mars. So the work on island dispersal patterns and the statistics and the mechanics of this will eventually, I think, play a role in modeling how life evolves in the galaxy. Some of the other islands that I've been fortunate enough to relate to were, for example, the Indonesian islands, which are the absolute other spectrum of the class of tropical islands, because what we have here in Hawaii, as I said, is mid-ocean islands far from continental floras and faunas. What we have in Indonesia is, in fact, a submerged continent. As recently as 120,000 years ago, Indonesia, from Sumatra to New Guinea, was a single landmass. And in the process of its subsidence, the sea filled in the low spots, so that there is a direct correlation between species differentiation on any two Indonesian islands and the depth of the sea between them. And these correlations have been shown over and over. One of the great conundrums of 19th century biology was the so-called problem of Wallace's line. Wallace believed that between the island of Bali and Lombok, and then going west of Celebes, you could draw a line which was the line of convergence between the Austral-Papuan biogeographical zones and the Asian-Malayan zones. And statistical studies, Ernst Mayr principally, have disproven this notion. However, I have collected butterflies and stood in these forests on both sides of Wallace's line in several places, and I completely understand, and in fact wonder about Mayer's conclusion. I completely understand Wallace's impression, because these forests are staggeringly different. The bird calls, the butterflies. But what Mayr seemed to show was that there was no distinct line. There was a gradient from Australia to Malaya in one direction and Malaya to Australia in the other direction. Island groups like this, and I haven't mentioned the Galapagos, but they are another one, are such obvious laboratories of speciation that when Darwin and Wallace and Walter Henry Bates and other people who were grappling in the 19th century with the so-called species problem set out to do their fieldwork, they just could not fail to be impressed by this peculiar theme and variation. But they could not understand whose fingers strummed the harp until they realized that similar populations separated by catastrophes such as the arrival of ocean water or a lava flow or something like that, then come under very slightly different selected pressures, which cause a very slightly different physical aspect to be taken on. And so in the Amazon basin, for example, you can move 2,000 miles and have only about a 15% replacement in certain butterfly species. In Indonesia, you can cross a strait of water 20 miles wide and have a 70% replacement in butterfly species. And Darwin and Wallace, familiar with these places, both continental floras and faunas and the island situation, finally figured out what the mechanism was. And it's a wonderful thing, butterfly diversity, for example, is a situation where diversity itself becomes and it confers adaptive advantage, because butterflies are largely predated upon by birds, and it's been shown in numerous studies that birds hunt a target image. They have an image of the prey. Well, if through the chance recombination of genes your wing color or wing shape pushes you outside the target spectrum, you will be ignored. And so, like us, so variety itself becomes a premium in the evolutionary game. Novelty itself then is preserved because novelty confers adaptive advantage in this situation of birds and butterflies. Well, I think the implications of these things lie close to the surface. Earth is a small island. We are making great changes in its ecological parameters. We are affecting its plant and animal populations. By studying how evolution has shaped island groups, we can appreciate, I think, our own small cosmic island, and perhaps eventually draw politically empowering conclusions from that.
What a wonderful view of things, Terence. It's marvellous, and a real delight. The main the evolutionary puzzle that crossed my mind in the view of what you said is that if islands have this tremendous role in speciation, as all evolutionists believe, and which in fact, as you say, with both Darwin and Wallace provide the classic cases, then if we have places where there are contact island chains and archipelagos have incredible rates of speciation in Southeast Asia. The Malaysian archipelago, including Malaysia and Indonesia, is unbelievably species rich, one of the great creation centers of the world of species. And that's the tropical forest I know best, having lived there. And that the quality of that forest, its creativity, from what you've said, would come from a combination of island factors plus mingling of two totally radically different floras, giving rise to all sorts of new possibilities and combinations.
And that it was pumped by the repetitive comings and goings of the sea, which repeatedly islanded populations and then reunited them in periods when the water was concentrated at the pole.
And presumably also pumped by the ice ages, which must have compressed all forms of life towards the tropics, and then there'd been a retreat again away from them at the end of each ice age. Well, that would explain a lot about the pumping, and it makes incredible sense about the Malaysian archipelago. What I don't understand is, on the view of this day, how the Amazon, which is the large non-island area, comes to be the other major central species creation and diversity.
The answer is very simple. It has simply been above ground a very long time. In other words, the Malaysian Australopithecine situation is probably no more than 70 or 80 million years that map has looked like that. The Amazon, on the other hand, has been above water 280 to 300 million years. So simply being in the tropics with 3, 4, 5 breeding seasons a year for many organisms, and never being inundated by seawater or catastrophe, allowed that incredible climax of speciation on a continental landmass. You're right, it didn't happen, as far as we know, in Africa, although Africa is so heavily impacted by human beings that any notion of its original natural history is impossible. But that's the short answer, that it was just above water a long, long time.
But then, you see, we have two methods of speciation. One is spontaneous production of species just by being around a long time, without island separation. The case of the Amazon. The other, we have all the well-understood neo-Darwinian mechanisms, speciation, pumping of things, mixing of gene pools, and so on.
Well, what pumped the Amazon situation on a micro level is the meandering of rivers. You see, it's very hard in a climax forest situation for any new mutation to have a salutary effect. But because rivers meander and destroy forests and create sandbars and an intermediate shifting zone of what is called uninhabited land, so-called predatory species can move in there. And that's where the speciation is taking place. Carl Sauer estimated that before the advent of culture, of human culture, it was the meandering of rivers was the force for modern plant evolution on the planet. It's a vast amount of this shifting of boundaries goes on. And it's in that shifting boundary that mutants, new forms, can get hold. That's why a predatory species will have the following characteristics. It will be an annual, and it will be a prolific seeder. It will be herbaceous, not woody. In short, it will be a weed. And that's what a weed is.
A pioneer species.
A pioneer species, a tremendously predatory species designed for open land, utterly unable to compete in the forest, but in open land able to take hold very rapidly.
Yes, I think though that this, there may be a certain proliferation just for its own sake. You see, I think isolation, new environments and so on explain one side of evolution. I think there's another side which neo-Darwinism can't explain because it puts too much emphasis on natural selection. And this is what Willis, you know, the great British botanist who lived on Ceylon, and knew the ocean flora well. In the 30s and 40s said all these things about evolution by divergent mutation rather than natural selection. And in Ceylon he showed that in the Podostinaceae, a group of water plants that live in streams with leaves that float on water, there's an amazing variety of species in streams and rivers in Ceylon, sometimes many different species growing in the same river. And any attempt to account for this in terms of, you know, marginal differences in leaf shape, giving, you know, selective advantage, just fails. And he shows the same is true of many flower patterns, many tropical leaf forms, and so forth.
Well, I think you'd have to look at this more closely, wings, and how variety itself it somehow confers advantage. I would go through those plants and look for very slight chemical variances in the gene expression, because probably this variety is to confuse some feeder, and that it's literally bewildering variety is an excellent defense against predation. I've always wondered why, like the hapu here, an excellent example. Here we have these two tree ferns. They're two distinct species. As far as I can tell, they're distributed in a ratio of 50-50 here. And one has little black stickery stems, and the other has a fuzzy brown soft stem. Well, what selective pressure caused stickers to work for one and down to work for the other, and they're standing right next to each other? It seems to me there must be drift of genes, or simple for variety itself.
But that's Willis's point, that you have, that the life itself is constantly throwing out new forms, novelties, that novelty is the essence of it, and unsuccessful novelties will be weeded out. The very successful ones will be a sort of wild success. But a lot of these novelties, which may just be different, you know, these two tree ferns work equally well in this environment.
Yeah.
There may just be lots of entirely equivalent things where you've got novelty for novelty's sake. And that this is the nature of the evolutionary process, and natural selection plays a much smaller role than if you try and explain all forms in terms of the close sculpting of natural selection.
Yes, in the Indonesian butterflies there is this concept of what's called the conspecific species, which means that when you're on Bali there is a certain butterfly, and then you go to Lombok and there is a butterfly which is different from that butterfly and cannot naturally cross with it, and yet is so obviously the same butterfly that it's the conspecific species, and they have been isolated in this way, and so by that means there's variation, and then sometimes these populations can be reunited, and some very small percentage can transfer genes, and then you get even more variety.
Well, getting back to Hawaii here, it seems that I understood you right, that what's unique about Hawaii is the Hawaiian Islands are young, and they're maximally oceanic islanded. They're far from the continent. And the process of the population of a new island from a neighboring island is visible, and even in the present, and then we see a certain pattern that's repeated over and over again, even in the course of a century. So it seems to me that these different examples you're talking about conflate two different processes, more or less, are projected upon the same screen. One is purely biogeographical process, which would be, could at least be imagined to be operating the same way without any evolution. We have only the same species that ever were, which we found on Maui, are suddenly appearing on Hawaii by a process of dispersal, pioneering the successful species, the creation of an ecology suitable for the second species, and their space-time patterns are developed one upon another in a very interesting fractal movie that to begin with would have nothing to do with evolution. On top of that, you have, I'm not sure what are the relative timescales of this, then you have an evolutionary process involving speciation after, either during or after the dispersal, pioneering, and what you call it, civilizational process of a brand new island. Is the evolutionary process essential to the population of the new island, or isn't it?
Well, I think in the short term it isn't, in the long term it is. Because any form of life arriving in these islands it's not home free. It's then got to contend with this kind of islanding by volcanic flow that I talked about, and other large-scale catastrophic events that are hypothesized to have gone on in the Hawaiian Islands. So basically what we see here is just genes being mixed and stirred probably at a faster rate than in most places. And that's without even mentioning the vast number of plant and animal introductions brought by human beings. One of the other unique things about Hawaii that I didn't enumerate was human beings arrived late. And this, in some sense, gives us a clearer picture of what happened. But it's almost as though Hawaii is a speeded up microcosm of the Earth itself, because probably 8/10 of the Big Island is in the pre-Archaeozoic phase. In other words, almost abiotic. And then large areas are covered by lichens, a fern or two here in the crevice, and then a small percentage of post-cometary impact forest of flowering trees inhabited by mammals.
So the biogeographical process, with or without a kind of modulation by speciation, is biogeographical process is a kind of recapitulation of evolution. That is, there's a resonance between evolution in the past and biogeographical development in the present. So the conflation of these two things is not an accident of thought, but because there's a resonance between these two processes.
They're fractal in relationship to each other. If you supposed that an animal's genetic heritage never changed, but that it moved across the surface of the Earth from one environment to another by being blown and swept there, then nevertheless you would get different forms of this animal because selective pressures are different in different places. So without any change in the genome at all, you would get a series of divergent forms through natural selection in the absence of gene.
That's why we're different from the little green men in the UFOs. Well, back to this resonance idea, you used the word pumping, and I like that, but I think it's a form of resonance. There's sort of a forcing or a coupling or a codependence between these two two different processes. There's a totally physical one, as for example, new lava flows, the meandering of rivers, the rising of the island, and then it kind of pumps the space-time evolutionary pattern formation
it couples
process
back into the Earth itself. Really, the ice ages are the pump. They raise and lower sea levels. They create deserts and drop humidity. They force change. And they are probably driven by fluctuations in the dynamics of the sun. And this is now pretty well in hand.
When therefore ought to correlate with the novelty wave.
And
have you tried mapping it against
yes,
the ice
thank
ages?
you for that opportunity to...
Well, I think we should have a figure of the correlation in our text.
Oh, I have all that.
You guessed. Well, let's put it in the ice ages and the novelty wave.
Good.
Well, I should just point out that the process looks a bit different if you take morphic resonance into account, which standard neo-Darwinian biogeometry doesn't. Well, habit then becomes a much more important process, habit formation. And we know that organisms adapt to new environments. Any given plant, you take seeds from any of these plants and grow them at different altitudes and in different climates. And in many they'd survive, but they'd look different from the way they do now. Grow them there for several generations and they can adapt, and they take on, as botanists say, a new habit. And I think you see that kind of habit formation gives you very rapid evolution. All of us can adapt to changed circumstances in a matter of days, or in the case of coming here, or years. Everything adapts without any gene change or organism change, and as it adapts, it forms new habits.
Well, behavior is that small margin of adaptability that is supposedly not genetically driven.
Well, behavior is one form of an adaptive habit, and we know those best. But the way that plants grow, for example, in different environments is another. They can vary enormously over a range of environments, in form and stature and leaf shape and so forth. So I think that this gives a much more rapid way of understanding evolution, because instead of just random mutation and sculpting by natural selection, you have a positive adaptation of the animal or plant itself to a new environment. It reacts and responds appropriately in a creative way, creating new habits, new subspecies, new forms of life. So the creative adaptation of life to new circumstances, in my view, is what's going on in a way that when you see a plant adapt or an animal learn a new and adaptive pattern of behavior, what you're seeing is the innate creativity of life in action, not blind random mutations, not just physical forces, not just natural selection, but a kind of creativity inherent in all life.
Well, I think it was L.L. White who pointed out that a great deal of selection goes on before an organism emerges from the womb, and that to pretend that natural selection operates on a tabula rasa is completely naive. The first environment is the environment of the womb, and many don't make it. So those who do have already been subject to a process of natural selection and winnowing that was quite intense and is applied to all species.
But there's still a large range that can pass through that. In the case of plants, where you don't have wombs, you've got a seedling stage, a fairly brief one. Well, no plant can survive that can't go through that, unless it propagates vegetatively. So they're vulnerable there. But the fact is, lots of seedlings don't look that different from each other. A lot of them, in the earlier stages, they're hard to tell apart. So you seem to have a fairly generic pattern there. The differences come out later in both animals and plants, the later formed structures. Anyway, I think that this creativity and adaptation enables us to understand that whenever you have all these physically new environments and meandering rivers, lava flows, recolonization, moving from island to island, and so forth, these, as you say, create new environments, micro-environments, and lead to a great deal of creativity. There's one other thing that this theory suggests is not only would you have this creativity through adaptation in individual organisms, you'd also, by morphic resonance, have transfer of forms from place to place. So conspecific species could be an appearance just by morphic resonance, copying of forms, like in the placental mammals and the marsupials, where you've got all these parallel forms.
Well, it would augment the natural selection of separated genera.
Yes. These things all work together. I mean, there's still natural selection of gene pools, but it's a rather foreshortened view of the whole process, which involves creativity, adaptation, spread of habits as well, in my opinion. And so I suppose the thing that puzzles me most really is why there haven't been more species and more forms in Hawaii. We look around this rainforest here, and there's just one or two tree species, whereas in a tropical rainforest in the Amazon or Malaysia it would be hundreds.
Again, the answer is time. 300 million years versus 20 million years. That's what it is.
Well, there's so many reasons to fail here. I personally find the environment harsh, lush as it may look to you or other people. And I suppose that one way a new species could fail is through having bad habits. There may be habits that manifest visually to us only in terms of spatial pattern. The colonization of the black lava by these trees, what are they called?
The ohia.
The ohia tree. This appears in a certain fractal pattern in which there are characteristic frequencies of distances that have to do, I suppose, with the distance the seeds fly in the wind or something like that. There is a certain spatial pattern which is the necessary one for survival that has a kind of a morphic resonance, a resonance of space-time pattern with the physical substrate itself. And other species, although they would look equally strong or stronger in the environment of a planetarium, if they dispersed in the lava, they can't make it because their spatial characteristic is wrong. So in the change of a species that may not involve DNA, could be a change of habit in terms of the spatial distribution. It could just be response to a nutrient because of a change of size and therefore characteristic distance in the space-time patterns. We seem to see that, well, first we see the lichen. The lichen creates just the minimum of degradation of the surface that makes it possible for the ohia tree to grab a hold. And the lichen, as a pattern, is obviously fractal. It's sort of characteristically fractal, and the lava surface is fractal as well. And fractal, if it means that there's a resonance across scales, then the lichen scale, which is much smaller, is nothing. There may be many kinds of lichen, but only this one grows because its fractal pattern is, in spite of the apparent difference in scale, because of resonance across scales, it has the right basic form, something like the time wave, so that, as a matter of fact, it's compatible with the bare rock. And then the ohia tree is compatible with its fractal pattern, apparently on a much larger scale, is nevertheless resonant, harmonious, as opposed to other species that might be disharmonious. And this harmony, this capability of a certain space-time pattern is a habit which may change and adapt in a way that requires no change in DNA at all. It's non-genetic variation, just in resonance to some kind of morphic field.
So you're talking about the evolution and development of whole ecosystems, and I think what's interesting about that is that these ecosystems get established, then there's repeated lava flows, and they're wiped out again and again and again. Divided, and then lava flows are recolonized. The entire ecosystem has to move, not just single species.
Yes.
So you've got a portable ecosystem.
Yes.
Maybe that's why it has to travel light.
And evolving one, or learning one too.
Good point.
I mean, Because the Amazon forest, to have the whole thing, to transport the whole of that, where they've some seeds drop to the ground, others are blown by wind, others are carried by birds. I mean, to get the whole thing to move, if the whole thing just had to move from place to place. I mean, what it's had to do in the past, I suppose, is adapt to changing rivers and adapt to shifting cultivation much more recently. But here, the whole thing.
But strangely enough, the Amazon too is an incredibly inhospitable place. It's all what's called podzolic sand. In terms of the way foresters measure these things, this is a much more hospitable place in that in the Amazon, at any given moment, I'm talking about, say, for instance, the Rio Guajaga Valley, 98% of all organic matter is bound within a living system. In other words, there's no detritus on the forest floor. There's no fallen leaf. Well, here, it's probably 80%, something like that. There is detritus. There are fungi. There are pockets of soil. The Amazon is in a frenzied state of recycling. A palm frond falls, and you pass the same place 20 minutes later, and it's gone. It was 16 feet long and 5 feet wide. It's gone. The ants have just taken it. And this is the rate at which it was estimated that minerals in rainwater falling in the Amazon flow an average distance of 1/2 centimeter before being completely bound and absorbed in the organic systems.
Well, there's so many trees per square kilometer, and there's this climax forest 200 feet high, and here everything is very sparse and thin. Is it just needs 250 million years or something to thicken up?
No, it's 19 degrees north, which is a long way north. It's a pseudo-tropical forest, in my estimation. It would not be nearly this lush if it weren't that its climate is created not by its latitude, but by the ocean. It is bathed by warm currents in the same way that England's climate is, in a sense, a godsend. Nobody that far north should expect temperatures like that, and nobody this far north should expect a situation like this. But it's just very mild, very stable, and that accounts for it. I believe it's on the latitude of the Moss of Life.
Going back now to this question of the morphogenetic field of an entire ecosystem, I'm bothered by the creation myth, and I just want to ask you guys about this. In this creation myth for the Hawaiian Islands ecosystem that you described, there are these islands which have already disappeared, and the ecosystem have jumped from them onto Kauai and so on. But as I understand, these islands are rafting along over this more or less stationary hotspot. Those earlier islands were also right here where we are sitting today, also very distant from any continental landmass. So is day one of biology on the Hawaiian island chain we are to understand, a result of long distance dispersion because of rafting and birds carrying, but then they had to recreate an entire ecosystem. It seems so coincidentally similar to island ecosystems elsewhere. Almost
because
impossible.
They've had to follow the same creodes and were constrained by the same process.
Nothing happened until the right lichen arrived after the failure of millions of years of bird and raft carried.
Well, the lichen, I suspect, it could probably be found in air samples above any point on the planet.
Yes, so you've got spores as the first colonizers.
Yes, and then the ferns come next. And of course, the reason the non-flowering plants conquered the planet, if you think about it, is because the planet was like Hawaii. It was new lava, it was endless lava flows, and the ferns could get cold. We think of ferns as soft and somehow spoiled plants. Actually, they're the toughest plants there are. When we study biology, they teach you psilotum. You have to dissect psilotum. It's held up as the most primitive land plant This forest is full of silos, and I can point it out to you. And
these guys are tough.
They're tough. Yes, this is
But how did they get here? These seeds are carried by birds.
Well, spores. No. Well, yeah, sure. Spores. Mud on the feet of migratory birds could carry millions of spores.
Well, this is one of my favourite explanations. John Michel particularly likes this. The Forteans, it's one of their beloved explanations. You see, the Forteans have studied the phenomena where you have new pools appear, lakes are created,
Right.
and so forth. And within 20 years or something, they've got all the things a regular lake should have. The right flora, tadpoles, the right kind of fish swimming in the water, daphnia, water beetles, and so forth. And the nearest lake may be many, many miles away. So the explanation for this, that's accepted without question, is that they all got there on ducks' feet. And so the duck's foot hypothesis is
Well, but spores, I think, are a little
spores,
more
all right,
reasonable.
spores are a little more reasonable. The Forteans have a great time with the duck's foot hypothesis.
Obviously,
which I
these
find
spores mutate into mallard ducks, cattails, minnows.
Well, no, they have their own explanation, the teleportation theory. You see, they believe that nature abhors a vacuum, and that when the right thing is needed by the ecosystem, if it's not there, it simply teleports it from where it is. So you need to assemble a tropical forest. You've got to have trees, tree ferns, liane-type vines. The whole thing's certain regulation things the tropical tree forest tropical forest morphic field ought to have. Hawaii satisfies those criteria with the minimum number of species.
Right.
But the fact is it has to have all those. And so they think that all these cryptozoological reports of pumas in Scotland and jackasses on Dartmoor and so on, that these things...
I'm sure that happens.
These reports of, they love these, and falls of fishes. The falls of fishes and the frogs, when animals just fall from the sky.
Well, can we agree that they represent sort of the trailing edge of a bell curve of probability?
No, I don't think we can, because I think that the reports are indisputable. Fish fall from the sky, people cracking open stones that have been there for thousands and thousands of years find living toads embedded within them. But you see, they take the teleportation hypothesis seriously. There's evidence of it in the human realm. Sai Baba seems to manifest things that could be teleported and so on.
If that's their best exhibit, they better run for cover. My God!
Well, I think that
there's my chickens
Touch one
along
of
with
Terrence's
Sai
buttons
Baba. Would you? Would you leave your chickens alone?
No, I don't think they'd be in danger of teleportation and would appear
at a minimum
somewhere else.
At a minimum.
Anyway, if species can move, there's a way in which they might be able to move or be reconstituted or in ways over and above spores, seeds, rafts, etc. And that, I think, may seem of minimal interest in the context of the Earth, a merely eccentric theory. It becomes much more interesting when we take up your theme of the Earth itself being an island and the biology on Earth being an island biology. When we then consider how things could have moved through from other planets in maybe other star systems, then ducks' feet are out, for starters. You can get in the sort of on the tail
that there's an underlying set of resonances that matter will flow along similar trios in similar regimes of chemistry and pressure, whether they're here or in orbit around Arcturus. And so, this is what fuels the expectation that on an Earth-like planet there would be Earth-like beings.
But I would say by morphic resonance, you see, because I think the two planets would be in resonance if it was sufficiently Earth-like. So you then have the idea of a kind of resonance phenomenon driving evolution, or leading to forms of life which have never before appeared there, but which have appeared somewhere else in the universe. Now, without the need for spores, seeds, or rafts.
Well, there are evolutionary puzzles that I think completely defeat any kind of Darwinism or neo-Darwinism. The prime example being the metamorphosis of beetles and butterflies. I mean, here is a process which involves the perfect coordination of hundreds, if not thousands, of genes simultaneously. Imagining any gradual process that would proceed gene by gene over eons to end up with something like that happening to an organism defies credibility. I just can't feature it. Clearly, thousands of genes were changed in one or two moves to achieve that, and no ordinary process of gene reshuffling that I'm familiar with could account for that. You do not hear this discussed.
No, it comes in that category of macromutation, which biologists don't like to discuss.
Right.
When you have a large change of a lot of coordinated things.
But after all, the insects are probably the dominant order on the planet in terms of biomass, in terms of species number, in terms of the number of environments they can inhabit. So in other words, the conquest of this planet by life preceded by a mechanism, metamorphosis, currently completely a black box to modern biology.
Well, I think there's a startup problem, whether on the scale of the whole planet or an island in the Hawaiian chain. I just can't imagine that the frequency of ducks flying is enough to allow the duck's feet hypothesis to explain the arrival of correct species and correct temporal sequence in so short a time. I mean, they would have to just be dumping literally dump truck loads of different genetic material on a daily basis on the brand new island in order to have a chance to get started.
The studying of banded birds and this seems to show that there's a lot of material moving around and that 1 million years is a long, long time, and that a number of improbable things can go on in 1 million years.
Well, I've been here for a week. I have not seen a new species of bird arrive from the mainland.
Well, stick around.
Well, has anyone ever worked out? I know they've banded the birds, all right, but have they counted the number of birds, the number of spores they can possibly carry in a full load?
What graduate students are for, Ralph. This is the work of the study of the Hawaiian Islands.
Well, on the planet,
Computer models of these birds coming and going from Vancouver and Baja California over
dumping a load and returning,
carrying 1/100th of a gram of biological material on each trip, and of those, 1 out of 1,000 survives, and out of those, and you discover no problem.
Well, okay, let's accept in part the duck's foot hypothesis in its broader form. Migratory birds. Pretty plausible. Birds do migrate from place to place over large distances. Indeed, many call in Hawaii. I looked up in your bird book and saw there were quite a number of migrants from different directions. So we accept this for the purpose of argument. Now, which is cause and which is effect? No one knows why birds migrate in the patterns they do. And the evolutionary basis for migration, sometimes we hear land masses gradually moved apart and they had to move further and further over oceans. But in fact, migratory routes are kinds of habits. New ones have evolved in recent decades in Britain.
No, I don't think it is migratory birds. I think that the process is primarily one of a novelty, unusual events, catastrophes. The greatest storm of the century. Every century.
Birds blown off
course. It's not about habits.
The pure numbers are reduced to such a small level that it's hard to imagine all of these coincidences necessary for the reconstruction of ecology.
A single freak storm veering off course might equal a century of ordinary dispersal.
But these migratory habits of birds are presumably quite old in many cases, and every time there's an ice age pumps the evolutionary process. Presumably birds that do migrate have to change the places they migrate to. In the last 10,000 years, the great bulk of Northern Europe and North America was opened up as a habitat, much more recent than anything we're looking at here. We have to remember we live in pioneer recolonized communities ourselves, as we come from most of the Northern Hemisphere. London, the ice cap went down to Hampstead in the north of London 10,000 years ago. Most of England is a recolonized and recently recolonized ecology, quite common. All the birds that migrate have to adapt over thousands or even hundreds of years, short-term adaptations. It seems to me that if birds have a kind of collective map which they share with other birds that have migrated and can tune into a kind of bird collective unconscious, that some species migrating over certain routes and knowing about Hawaii may enable others starting off in that direction to follow a kind of pre-existing creole, rather like existing jet flight paths. I was amused when we came here to Hawaii. We were flying in this jet plane, and outside the window, about 100 feet away, was a vapor trail which we followed exactly for 2 hours, presumably of the previous jet flying to Hawaii, and they were 100 feet apart. So there may be kind of creole memory channel bird migration paths, and many species often follow the same paths, like around the Mediterranean coast and over the Straits of Gibraltar into North Africa and so on. Mm-hmm. So we could have a whole kind of bird mind, and when the Hawaiian Islands appeared, long-distance migrants like albatrosses or whatever the largest seabirds are here, that in any case spend a lot of time at sea, recognize this fact and start coming here. Somehow this gets into the bird net, and other species, rather than whole flocks of them starting out lemming-like from the coast of California in the hope of finding an island by chance 2,500 miles away, are actually doing it with a great deal more confidence. Mm. Then we'd have the idea of the appearance of new land if it actually channeled bird migration routes towards it, because the word got around pretty fast and they were able to adapt. And then the duck's foot hypothesis would still be plausible, but plausible for a different reason.
For this direction by a committee in the sky, the Vacuum Abhorrence Committee. Whoops. In New Ireland Pacific, tell the albatrosses do their job as sort of a pack train to bring as much genetic material as rapidly as possible and dump it on the new islands.
Sounds like one of the adventures of Dr. Doolittle. You can see. Well, I think there are one or two more points if you've time and patience.
Sure. Let's do it all.
If you can wait just a moment.
When a new island comes up, then the entire database of the migratory birds and all the other species is somehow informed of this, that geography is the basis of biogeography after all.
Well, this came up just the other day. How did the original people who came here find it? And one obvious hypothesis that struck us was that if they were keen observers of migrant birds, they'd notice that birds set off from their islands in a particular direction and came back again, and it would therefore be a fairly simple deduction that if you follow the migrant birds, you'll reach land sooner or later.
That's right.
That's what East is a big bird means. So following the birds then is no less of a mystery than the birds themselves being able to migrate. So either the people could follow the birds who navigate by some unknown mysterious means, or the people could have had access to similar mysterious means themselves. And when a new island comes up, then the information is somehow injected into their own migration patterns, which is whatever guides them, which they may consider to be celestial navigation or whatever, in their canoe rides from one island to another.
Well, all we have to do is to add in the cetacean factor, and we'll have a complete series. The animals that presumably noticed, first of all, that volcanoes are erupting beneath the sea 2 or 3 or 4, 10,000 feet down, causing a great deal of hissing, steam and commotion, presumably marine animals.
Sure.
Fish, things, dwellers on the marine floor, and presumably there's a whole microenvironment of warm water-loving creatures that moves along the base of the islands.
Thousands and thousands of miles.
And the whales have this telegraph system, and they send telegrams to each other, and then finally the dolphins know, and they communicate to birds with friends and bears. The very fact that it's all tied together, as it were, is the only reason that it can all work, and that without the tying together of all living things in one giant worldwide web, there would, as a matter of fact, be no life. Certainly no new life on a new island like Hawaii.
Sounds reasonable.
Yes, I think so.
I mean, if one isn't too tightly constrained in the definition of communication, it obviously.
And without the communicative web, the informational sharing system, then it's all impossible. And even though we don't know how these communications take place, nevertheless we can sort of deduce that without communication it doesn't work. Interspecies communication makes it all go.
Yes. And if we, this is an idea again that came up when Ralph and I were talking a couple of days ago. We postulate that plants have a kind of dolphin or whale-like telepathic relationship between them. Then plants of similar species on different continents would be able to read out an oak tree, for example, now planted on every continent and native. If you take in the whole genus, you'd have a wide band of the old world and the new covered. If any of these, if they were linked or resonating together in a complete kind of oak mind, any one of them would know what was happening with the weather as a storm passed over Wales, and the oaks all registered it, and they'll stay that it closed or opened or whatever, or as some great catastrophic lava flow occurred somewhere else, and made Mount St. Helens erupted or something.
Well, I think John Donne covered this territory. No man is an island entire of himself. Each is a part of the continent, a part of the main. Each man's death diminishes me, therefore I have never sinned to know for whom the bell tolls for thee.
But the conversation of the oaks that transcends that homocentric view a little bit. This is closer to children's books, children's stories, and the lost mythology of the communication of humans, animals, and plants. That we're proposing is, I think, for many people, stranger than a living toad inside a dead rock.
That is the basis of shamanism worldwide. It's what shamanism is all about. Communication on this interface between the human world and the world of plants and animals. And presumably it's shaman who discovered the powers of plants, the humanly relevant powers of plants, including the psychoactive powers of plants, and explore them. And it's shaman who entered the mind of animals and have animal totems and animal spirits and can find out the ways of animals for practical purposes. So if we see this communication, we see that pets, as we were talking about, can find out what people are up to in surprising and astonishing ways at a distance. We've already got ingredients that point towards the possibility of a worldwide web of communication between plants and animals and people and so forth.
Well, I think the technological principle on which the next century will operate is the mimicking of nature. Solid state, micro-miniaturized, solar-based, no moving parts, so forth.
But a lot of that is the mimicry of nature as perceived through a filter so narrow that maybe the most essential functions of nature are not even recognized, and therefore what is mimicked is a non-working skeleton of a dead nature, as it were.
Well, for instance, solar cells obviously depend on an understanding of photosynthesis, and it would be a brighter world if all electrical power were produced that way. Similarly, processes of fermentation are better than processes that require more high molecular weight solvents.
It sounds right, but actually I think that photoelectric devices as known today are not only much simpler than photosynthesis, but they were understood at a time when photosynthesis was not understood, and even now is not. The whole chain is perhaps not completely clear.
And they take the bare essentials but leave out the whole of plant morphology.
But
all these plants are photosynthetic.
Solid state quality, that's all I'm saying.
Well, they started to make them as single crystals, and this is very expensive, so when they make them more fractals like plants,
the amorphous silicon.
Yes. So I think that the imitation of nature would be disastrous if we can't learn to see it better, that somehow we need more means of opening the scientific stranglehold on the observational powers of the human.
Well, but there are currently only two aesthetic schools on the menu, the imitation of nature.
But we're leaving out the alternative that arises from the possibilities we're talking about. I mean, if nature involves this worldwide web of communication, if there are flows of information from people to animals, animals to people, migrating birds, dolphins, and so forth, all these things being reflected in the population of this isolated set of volcanic islands.
It sounds like connectivity is the overarching.
And now we come to the true spiritual purpose of the digital World Wide Web, which is a training ground for appreciating the mechanism and the characteristics, learning to observe the global phenomena of World Wide Webs, so that with this training in childhood,
so it's an analog for nature.
Yeah.
Quite. At present, we're limited to analogues of mechanics, and in the case of morphic resonance, radio and TV, because the underlying metaphor is radio and TV. But here we have another metaphor, and since science can only work in terms of metaphors, and so far it's only worked in terms of mechanical metaphors, here's an expanded mechanical metaphor. But I think it would only really work if it converges with an expanded mental or psychic metaphor, and I suppose the psyches of the people connected through the web are that. I mean, the thing lacking from it as an evolutionary model, to me, was the lack of it having a field-like quality, but just a kind of series of interconnected bits, rather like in these artificial life models, where you just have units that join up. I think a field-like quality would be make it much more interesting. That could happen if the community of people doing it followed the suggestion of the Russian eccentric Konstantin Ivanenko, who is always writing to me with his scheme for a total transformation of humanity through people linked up by computer nets, chanting together at the same time and intentionally creating what he calls a psychotronic revolution, which would entrain the consciousness of all those doing it more than just the operation of the mechanics of this thing does, by synchronized chanting, which would be coordinated through the net itself.
Very interesting.
That's his vision. He's been going about this for years. He thinks that could cause the emergence of a shift in consciousness. The network won't do it by itself. And I think that that's what's lacking from the network by itself and from the standard physical linkage theories of evolution.
Even if we sort of the harmonic convergence idea, if we all go stand on nearby mountaintops at exactly the same instant throughout the entire biosphere, then somehow that would precipitate phase transition.
Exactly, and many people would ridicule this as saying this is what peace protesters were doing all through the 70s, visualizing peace all over Eastern Europe and the ending of the Cold War. And as the smile comes to their lips, it tends to freeze, because of course that's exactly what's happened. And
although the harmonic convergence is a less successful piece of evidence and seems to indicate that this area of thinking can become a reality of diseased intellect.
But it shows that people go for it and that really respond to it, because otherwise why would so many of us have been gathered in obscure parts of the globe chanting at dawn, in my case at Glastonbury, in a light drizzle, along with Sir George Trevelyan on the top of Glastonbury Tor. How are so many people engaged in this activity if it isn't deeply attractive?
And we Americans can answer this question for you. It's called hype. And we've perfected it, and I think you were hype.
Hype is a resonance phenomenon, but not the only one.
But hype only certain kinds of hype work. All the subsequent ones he's convened haven't. So this one actually worked in a new kind of way. And you see, I think it's possible that if we look at the whole world, there may be a kind of global chance triggered off by sunspot cycles. Life all over the world may, just as it has pulses through the ice ages, it may be being pulsed.
Any theory which has us gathering together in large crowds to chant should look back at the Third Reich before it proceeds too far with its agenda.
Well, in this case, they're not in large crowds. They're spread out over the surface of the earth, or in front of their computers.
Homegrown fascism. Decentralized fascism.
Well, it shows that only if there's a ritual or a kind of conscious, intentional, resonating aspect to this, will this network have any kind of dimension of a field? Because this could create a field.
Well, but in a way, when you think of it, the whole Nazi thing was the invocation of a field.
It was very successful.
Group resonance. It was an appeal to the folk mind.
Well, so were all calls to war by nations, bishops, crusaders,
This is why I think Heidegger was far wrong when he said the way you judge reality is by the depth of the call, because the call can be deep and it can still be haywire.
I know, but you see, we're all the victims of a call to move west, for example. I mean, we've wound up here, now at the ultimate limit of the west. Well, except the westernmost Hawaiian island, I suppose. The Trialogues at the edge of the west have made it...
Here we are.
A further 2,500 miles. So there's this westward elan which causes... well, in the case of the British, it was an eastward movement. I mean, migratory peoples migrate to England, Anglo-Saxons settle, etc., sort of wipe out the native people or subjugate them. They're on the move again after a few hundred years. The British Empire, the settlement of North America, and similar process from Spain. And now, having gone right across North America, subjugated and they wiped out its natives, eliminated their culture, the whole process has moved here, and we can see that happening before our very eyes. Something which, in terms of evolution, shows the opposite of everything we've been talking about so far. Now there's no separation of the islands from TV networks and satellite linkages and the internet itself.
Well, one of the most frightening trends, I think, in modern culture is the wish to build shopping malls everywhere. There is a mentality that would like to turn the planet into an international airport arrival concourse. That's their idea of utopia.
Based on America. The model for all of this is always America, you see.
I suppose.
And so now there's this kind of clonal culture moving worldwide through media, which has the opposite effect to all the speciation, diversification and evolution and creativity we've been talking about. So we see the opposite process at work in Hawaii today.
It's like
stifling of the native culture.
America's a cultural bulldozer.
Yes.
It just tramples and destroys everything in its path.
But that, you see, is simply an expression of this westward migratory urge which underlies all the people who migrated to America, of whatever race and background. They all migrated, that's what brought them there. And this migratory urge, which has been, I suppose, very strong in all sorts of human populations. And indeed, maybe just yet another manifestation of the migratory urge we see in birds and in plants and indeed in the movement of life from planet to planet.
And there appears to be a double gradient here with the eastward migration of Asian people kind of balancing the westward migration of European people. And this is actually the interface where the double gradient can produce an increase of novelty and new mutations and forward leap, perhaps, of human evolution could be here because of this double wave phenomenon.
A standing wave
A standing
forming
wave.
here as forces move both east and west.
So, can we point to any human creativity of Hawaii that exemplifies that, like in the Malaysian archipelago, the coming together of two great flora and fauna systems, ecosystems? Can we see that creativity in evidence? I think noticed
Well, I
it
suppose Pearl Harbor was the moment of the greatest impact of East and West, and as a result of that, of course, was the deployment of nuclear weapons. And whereas we don't like this, it is definitely a novel evolutionary or counter-evolutionary step. It's creative, hate it as we might.
And Pearl Harbor itself, being a volcanic derivative, has this kind of volcanic effect on world politics. It's interesting that radiated out the whole political geography of today was shaped by Pearl Harbor, as we know from all elementary accounts, with a lot of background and so on. But there we have another role of Hawaii. I wonder if you've reflected on that.
Well, certainly the defeat of fascism and the solidification of American opinion to go with Churchill relied on that, to the point where some historians have felt that Roosevelt knew what the Japanese were planning and he allowed it to happen because he wanted to go with Churchill and he couldn't figure out a way to solidify opinion. So yes, that was its moment on the geopolitical stage.
But it was also the moment of conflict of Eastern and Western power. The Japanese sought to expand their influence in the world, and were held back by military means in the end. They've now succeeded economically where they failed militarily, and here in Hawaii, at least politically,
This was
Japanese control
Eastern Vienna. If the Turks were stopped at the walls of Vienna, then the Japanese were stopped at Pearl Harbor. So that's the domain. From Honolulu to Vienna, that's Western civilization's turf.
But is it really the creative interface it could be between East and West? Because now it's a kind of stalemate, with roughly half of the island's population coming from the East and half from the West, with the native Hawaiians trapped in between.
Well, I think the specific rim culture that is hypothesized to be emerging, Hawaii is central to all of that. It's equidistant from Sydney, Lima, Tokyo, and Vancouver.
Have they adopted the slogan, "Come to Hawaii in the Pacific Hub," yet?
If they haven't, I'm sure they're not far behind. The presence of these telescopes here makes it a center of world science, at least in astronomy. I think the world's first, second, and third largest telescopes are on this island, with an identical twin of the largest being built a few hundred yards away from it. And the Maxwell 4mm, there's an amazing concentration of science on its field.
So it's a channel, perhaps, at least in the human realm, for linking us with the stars. Another important theme.
We're looking out
in our
from the top of Hawaii. Chosen paradoxically for being the darkest place.
From here they'll see the next wave of duck's feet
on there
arriving for the Biosphere 2.
Well, what do you think?
I think that covers
the waterfront.
most of it.
Round to a halt.